hundreds of millions, then the scrapyard. New York and Amtrak poured over $70 million into rebuilding sleek, high-speed turbine trains, and then watched them rust into hulks before selling them off for scrap pennies. This video unpacks how that happened. The vision began with the promise of speed and modern passenger comfort along the scenic Hudson River. In the late 1990s, New York State and Amtrak set out to modernize travel on the Empire Corridor between New York City and Albany. The centerpiece of this ambitious plan was a fleet of rebuilt gas turbine train sets designed to travel at 125 miles per hour. The state positioned the refurbished Turboliners as modern passenger transport. Originally built in the 1970s by Rohr Industries, these trains would receive complete, top-to-bottom overhauls, turning them into high-tech symbols of a fast rail network. The train sets used aircraft-style gas turbine engines, promising rapid acceleration and a smoother, quieter ride. For a public tired of highway traffic and aging transit options, the Turboliners offered an attractive alternative, a high-speed link to shave minutes off the trip between the state capital and Manhattan. Transportation officials envisioned a coordinated network where passengers could board a state-of-the-art train, access updated amenities, and travel at speeds competitive with driving or flying. The partnership between the state and the National Passenger Railroad was supposed to show that American infrastructure could match the fast rail systems found across Europe. It was a bold promotional push centered on a high-speed future, positioning these rebuilt turbines as the premier solution for regional transport. The 142-mile stretch of track connecting New York's Penn Station to the state capital in Albany, Rensselaer, was the chosen testing ground for this high-speed experiment. Known as the south end of the Empire Corridor, this route hugged the eastern bank of the Hudson River, serving a dense, politically active commuter base that demanded faster, more reliable transit. To New York transportation planners, achieving a true high-speed rail corridor required more than just incremental track work. It demanded a flagship fleet that could capture the public's imagination, run at sustained high speeds, and prove that passenger rail could successfully compete with the expanding interstate highway system. The Turboliner rebuild program was designed to be that very centerpiece. This was not a routine maintenance contract or a minor midlife overhaul of aging locomotives. It was a highly publicized, state-backed industrial policy. By upgrading the physical train sets alongside planned track improvements, officials believed they could slash travel times between Albany and Manhattan by 20 minutes, bringing the total trip under 2 hours. The state committed tens of millions of dollars to this effort, aiming to establish New York as the premier model for regional high-speed rail development across the United States. Placing such an enormous policy burden on a single fleet of niche passenger trains, however, required total confidence in their engineering. The state was betting its entire high-speed transit strategy on a specific, existing family of trains that had already spent decades operating on these same tracks. To understand why New York and Amtrak chose to rebuild these particular gas turbine units instead of purchasing modern off-the-shelf diesel locomotives, it is necessary to look back at how these European-inspired streamliners first arrived on the Empire Corridor during a very different era of American railroading. Amtrak first turned to gas turbine technology in 1973, importing French-designed RTG train sets built by A&F. These 5-car fix featured a 1,140 horsepower turbine engine capable of reaching speeds of 125 miles per hour. Operating initially in the Midwest, these sleek European streamliners offered Amtrak a striking, modern identity during its early, uncertain years. The turbine design promised rapid acceleration and a quiet, vibration-free ride that traditional diesel locomotives of the era simply could not match. The appeal of this fast, lightweight equipment led Amtrak and New York State officials to seek a domestic version tailored to the specific demands of the Northeast. In 1976, Amtrak placed an order with Rohr Industries of Chula Vista, California, to construct 7 Americanized versions of the French design, designated as the RTL Turboliner. Delivered between 1976 and 1977, these Rohr-built train sets featured major engineering changes to adapt them to regional infrastructure. The power cars received a more powerful 2,280 horsepower turbine engine, doubling the output of their French predecessors while retaining the design speed of 125 miles per hour. To navigate the historic restricted approaches into Manhattan, Rohr equipped the trains with third rail shoes, allowing them to draw electricity in underground tunnels where burning fuel was prohibited. Designers raised the car floors to align with high-level station platforms, installed standard American couplers, and outfitted the interiors with modern carpeting and styling. These 7 RTL train sets quickly became the face of the Empire Corridor, running daily between Grand Central Terminal, Albany Rensselaer, and Western New York. To the traveling public and transportation planners alike, the fleet represented a highly credible leap forward. The trains looked fast, felt modern, and established a distinct premium identity for regional travel along the Hudson River. This technological inheritance formed the backbone of New York's passenger rail service, operating for decades and establishing the very operational profile that future policymakers would eventually choose to revisit. The immediate enthusiasm surrounding these sleek streamliners obscured a harsh operational reality. Gas turbine propulsion systems relied on continuous high-speed rotation to run efficiently, unlike diesel engines that consume less fuel when idling or running at low speeds. A gas turbine burns fuel at a nearly constant high rate, regardless of the train's speed. This meant that on corridors with frequent stops, slow terminal approaches, and station delays, the fuel efficiency plummeted. When fuel prices fluctuated sharply during the global energy crises of the late 1970s and early 1980s, the operating math for these trains collapsed. In the Midwest, where Amtrak ran its original French-built units, the financial burden of this fuel consumption quickly became unsustainable. These train sets consumed vast amounts of expensive, aviation-grade kerosene compared to traditional diesel-electric locomotives. By 1981, facing rising deficits and volatile energy markets, Amtrak withdrew the entire Midwestern fleet from service. The move was a clear admission that the superior acceleration and smooth ride of turbine technology could not offset its extreme operating costs. While the New York fleet continued running on the Empire Corridor, physical vulnerabilities became apparent alongside these economic pressures. The intense heat generated by aviation-style turbines placed constant thermal stress on engine components, electrical systems, and fuel lines. During the late 1980s and early 1990s, this heat led to a series of dangerous onboard fires. In 1990, a serious fire on a Turboliner prompted an investigation by the National Transportation Safety Board, drawing attention to fuel delivery systems under high temperatures. The safety risks became undeniable in 1994, when a major engine fire broke out on a unit inside the subterranean tracks of Penn Station in Manhattan. The fire forced passengers to evacuate into dark tunnels and filled the underground platforms with thick, toxic smoke. Following this incident, Amtrak immediately retired the 3 remaining French-designed units operating on the corridor. These failures were not isolated mechanical flukes. They were structural warnings that turbine power plants carried inherent safety and maintenance risks. The high-temperature environment of a gas turbine required strict maintenance protocols, specialized replacement parts, and constant monitoring. By the mid-1990s, the physical evidence was clear. Turbine trains were expensive to run and prone to destructive thermal failures. Yet, as the decade drew to a close, transport planners looking to accelerate the Empire Corridor chose to look past these warnings, planning to rebuild the aging fleet for an even more demanding high-speed role. In September 1998, New York State Amtrak and the Federal Railroad Administration launched the High-Speed Rail Improvement Program, a joint initiative to modernize passenger rail along the Hudson River. This program established a coordinated funding framework of approximately $185 million. Unlike traditional transit spending that funded locomotives in isolation, this program was designed around a dual-track strategy. It paired the complete rebuilding of the existing Turboliner fleet with major corridor infrastructure upgrades, ensuring the rolling stock and the rails advanced in tandem. The policy logic was straightforward. A high-speed train cannot operate effectively on low-speed tracks. Under the program's guidelines, the partners targeted a sustained operating speed of 125 miles per hour on the critical segment between Schenectady and Rensselaer. To support these speeds, the program planned the installation of a second mainline track to eliminate a notorious single-track bottleneck, alongside modern signaling systems and bridge reconstructions. By funding both the hardware and the infrastructure together, transport planners aimed to shave 20 minutes off the trip between Albany and Manhattan, bringing the total travel time under 2 hours. The division of institutional roles within this partnership was highly structured. The Federal Railroad Administration provided regulatory oversight and grant monitoring. Within the state government, the program was administered by the Freight and Passenger Rail Bureau of the New York State Department of Transportation, which managed the capital budget and oversaw the reconstruction process. Amtrak, as the national passenger operator, was tasked with handling daily operations, maintenance, and tracking performance. An important contractual provision governed the ultimate custody of the assets. The program stipulated that ownership of the rebuilt train sets would transfer to the state of New York, but only after they successfully met Federal Railroad Administration safety standards and entered active revenue service. This performance-based transfer clause was designed to protect the state's financial exposure, ensuring that taxpayers would not inherit the physical assets until they were certified and operational. The entire modernization effort was thus anchored in a framework of shared risk, balancing state capital against federal oversight and railroad operations. In March 1998, the state of New York selected Super Steel Schenectady, a subsidiary of a Wisconsin-based industrial firm, to perform the complex overhauls. Operating out of a newly acquired facility in the Scotia Industrial Park, the company began hiring specialized local labor to transform the retired Roar-built equipment from the 1970s into the high-speed RTL-3 fleet. The state's initial contract was valued at $10.4 million to rebuild the first 2 train sets, promising the first refurbished units in revenue service by late 1999. But the scale of the ambition grew rapidly. In September 1998, the program expanded through a $74 million contract amendment to cover the remaining 5 Turboliners, setting a target to deliver the entire 7-set fleet in a high-speed configuration. Payments were structured strictly around milestone completions, tying disbursements directly to physical progress. At the core of this agreement was a decisive legal trigger, the ownership clause. The contract dictated that although New York State was funding the massive rebuild, it would not assume legal ownership of the train sets until they were certified by the Federal Railroad Administration and actively running in daily revenue service. The in-service requirement was meant to protect taxpayers, ensuring the state only took custody of a proven, operational, high-speed fleet. However, it also created an unforgiving operational bottleneck. If the trains suffered mechanical setbacks during testing, or if Amtrak refused to accept them into service, the assets would remain in a state of legal suspended animation. The contract tied public expectations, state millions, and private manufacturing to a single, high-stakes outcome. The rebuilt trains had to run flawlessly, or the entire $74 million program would unravel before New York ever owned a single passenger car. The late 1999 target for the first two refurbished train sets came and went without a single wheel turning on the Empire Corridor. Inside Supersteel's Scotia facility, workers stripped the 1970s Roar-built car bodies down to bare metal, only to discover extensive structural deterioration and hidden rust that required immediate, unscheduled structural repairs. As engineers attempted to move forward, they faced severe compatibility challenges. They were trying to merge modern, computerized electronic systems with physical shells designed in a completely different technological era. Wiring schematics did not match, and physical space within the aging car bodies was too tight for modern components, stalling progress on the assembly floor. By August 2000, the program managed to roll out the first rebuilt train set for a public ceremony. Painted in a gray and blue scheme modeled after Amtrak's new Acela Express, the train set looked complete. But the public display was a facade. Underneath the fresh paint and carpeted interior, the critical propulsion and control systems were unfinished. The train set returned to the Scotia shop immediately after the event, and the year 2000 closed without the train starting revenue service. As 2001 began, engineering setbacks multiplied. Amtrak operations staff reviewed the locomotive cab and rejected the layout, demanding a complete redesign of the control desk and console placement. Supersteel had to halt production, rip out newly completed wiring assemblies, and re-engineer the operator workspace to meet these new specifications. At the same time, engineers struggled to get the computerized fuel control systems to communicate reliably with the French-designed Turbo-Macula turbines. The high-temperature operating environment of these aviation-style engines demanded exact fuel flow calibrations to prevent overheating, but the new digital processors repeatedly failed to sync with the analog throttle valves. Every adjustment required new engineering change orders, and the entire year of 2001 slipped away in a cycle of redesign and retesting. By 2002, the schedule erosion had turned a series of minor delays into a systemic crisis. All 7 train sets were supposed to be carrying passengers, yet none had been certified. The mounting delays drew the attention of the New York State Comptroller, who launched an audit into the project's soaring costs. Investigators revealed that the first 2 train sets alone had already consumed $34 million, far exceeding the original $10.4 million budget. Despite this massive expenditure, Amtrak refused to accept the equipment, pointing to ongoing mechanical faults during test runs. Only in April 2003 did the first rebuilt Turboliner at last begin passenger service. It was a compromised arrival. The years of delays had drained all institutional goodwill, leaving the fragile partnership with no room for error. While Supersteel worked to deliver the rebuilt train sets, a far more fundamental obstacle was hardening along the actual steel rails of the Empire Corridor. The grand promise of 125 miles per hour service was entirely dependent on a parallel investment in track infrastructure. To achieve these speeds, the High-Speed Rail Improvement Program required the construction of a second mainline track on the congested segment between Schenectady and Rensselaer, eliminating a single-track bottleneck that routinely delayed traffic. The program also called for extensive bridge reconstructions, modern signaling installations, and upgrading the physical line to Federal Railroad Administration Class 5 standards. None of this infrastructure was ever completed. The physical path between New York City and Albany remained a legacy corridor, restricted to a maximum speed of 79 miles per hour. This speed ceiling was both a regulatory hurdle and a physical constraint of the tracks themselves. Without Class 5 tracks and positive train control, the route remained legally bound to Class 4 standards. The high-speed Turboliners would be trapped behind slower passenger runs, unable to use their expensive propulsion systems. The problem went deeper than unlaid rail. In New York, passenger trains run on tracks owned by private freight railroads. The primary gatekeeper of the Empire Corridor was CSX Transportation, which owned and controlled the right-of-way between Poughkeepsie and Schenectady. To run passenger trains at speeds exceeding 79 miles per hour, Amtrak and the state needed to secure formal, high-speed lease agreements with CSX. These leases were essential for defining track capacity, liability, and dispatching priority. Negotiations stalled. CSX, protective of its high-volume freight operations, resisted accommodating faster passenger service without massive, costly capacity guarantees. The carrier prioritized its own freight traffic, knowing that adding fast passenger runs on a shared, bottlenecked route threatened to congest the main line. While a basic operating agreement existed, a dedicated high-speed lease was never finalized. Amtrak and New York State had spent millions of dollars engineering a fleet of advanced high-speed trains, but they had failed to secure the legal right and physical space to run them at speed. The Turboliner program was built on a fatal mismatch. State-of-the-art rolling stock built for a high-speed corridor that existed only on paper. When the first rebuilt train set entered service in April 2003, the daily reality of operation quickly shattered the marketing campaign. On hot summer days, the retrofitted air conditioning compressors repeatedly locked up or failed entirely, turning the passenger cabins into sweltering, uncooled metal boxes. Riders faced stifling temperatures, prompting a wave of heat-related complaints to Amtrak. Simultaneously, conductors struggled with a rigid seating layout. The 5-car fixed consists offered only about 100 to 150 seats, with no ability to add or remove individual coaches to meet peak weekend demand. Behind the scenes, mechanics watched the fuel logs with growing alarm. The upgraded Turbo-Mica Makila gas turbine engines burned aviation-grade kerosene at a punishing rate, regardless of the train's speed. Stuck on legacy tracks at 79 miles per hour, the turbines consumed fuel almost as fast as they would at top speed, yielding terrible fuel economy. For both the crews and the engineers on the ground, the sleek streamliners remained an expensive, inflexible liability in daily service. In December 2003, the Amtrak Board of Directors voted to exit the partnership with the New York State Department of Transportation. The decision was driven by more than mechanical flaws and high fuel costs. The shared vision between the two organizations had completely collapsed. Amtrak refused to accept any more rebuilt train sets from the Scotia assembly plant, halting the program with only 3 of the planned 7 units complete. The railroad's leadership argued that running expensive, fuel-thirsty gas turbines on legacy tracks restricted to 79 miles per hour was operationally indefensible. The trust between State Rail Bureau officials and Amtrak's management had vanished. The end of the service came quickly. By June 2004, Amtrak stopped using the rebuilt Turboliners altogether, pulling them from daily service along the Hudson River. The train sets that were supposed to symbolize the future of fast rail in New York were instead towed off the main line and sent into storage. While the mechanical setbacks were real, the deeper failure was the unraveling of the partnership itself. What began as a joint venture to modernize the Empire Corridor dissolved into finger-pointing and broken agreements. New York had provided the funding, but Amtrak controlled the tracks, and the two entities could no longer agree on how to run the service or who would pay for the mounting expenses. With the contract ended and communications broken, the joint program lay in ruins. The state was left with millions in empty investments, and the National Railroad was left with equipment it refused to run, ending the high-speed dream in silence and stored train sets. In August 2004, the New York State Department of Transportation filed a federal lawsuit against Amtrak in the Southern District of New York. The state argued that the National Passenger Railroad had breached its March 2000 agreement to operate and support the rebuilt fleet. New York's legal claim grew to $477 million. This figure represented the state's calculation of its total expected benefits, including $185 million committed to capital construction, alongside an estimated $300 million required to operate the 7 Turboliners over a 15-year service life. Amtrak contested the allegations, pointing back to the state's failure to deliver the completed high-speed track infrastructure. After 2 years of litigation, the parties reached a settlement in 2006. Under the terms of the agreement, Amtrak paid New York $20 million to resolve the state's outstanding claims. Amtrak also paid $5.5 million directly to Supersteel to cover the remaining unpaid work performed at the Scotia assembly plant. The settlement closed the legal case, but it left taxpayers to absorb the rest of the $70 million loss. The final balance sheet of the modernization effort presents a stark calculation of public waste. A total of $70.3 million in taxpayer funding was spent on the rebuild program. In return for this direct capital outlay, the state received only 3 completed and certified train sets. The remaining 4 units were left behind at the Scotia assembly plant as unfinished, stripped-down steel hulks. Once the brief passenger operations ceased, these idle trains became a recurring expense rather than a public asset. Storing the 3 completed train sets and the 4 unfinished shells cost the state approximately $150,000 every single year. This storage bill accumulated annually, long after any hope of running high-speed passenger service had disappeared. In December 2012, New York officials cleared the remaining fleet from storage. The state auctioned 4 surplus Turboliners, comprising 8 power cars, 12 passenger coaches, and a warehouse of spare parts to local scrap recycler N.H. Kellman for roughly $420,000. Dismantling of these units began in 2013 as torch crews cut the frames into manageable pieces. Meanwhile, the 3 fully rebuilt RTL-3 train sets that had briefly carried passengers were towed south to an industrial yard in Delaware. The yard operators cut up the passenger coaches to sell as raw metal. The remaining locomotive shells were stripped of their turbine engines and repurposed as stationary training hulls for emergency rescue teams, ending any possibility of a physical legacy for the fleet. Today, America's dream of high-speed rail remains stalled by the same old obstacles. The Turboliner warning is clear. Cutting-edge trains cannot outrun neglected tracks or fractured political wills. Until we build foundational infrastructure first, the most advanced locomotives will remain stalled. We cannot build tomorrow's transit on yesterday's rails. Share your thoughts on the future of American rail in the comments below.